Well, good afternoon. Glad to see there's a few people who wanted to turn up and hear about what we've done on Windows Server 2012. So how are you guys finding it so far? Have you learned enough about Windows Server 2012, all the options, all the features, maneuvering around what works and what doesn't work? So how many are running Windows Server 2012 here today? Anyone? Windows 8? Okay. So how are you finding Windows Server 2012? You know, I guess it's the first day. There's probably several sessions that you could attend to give you access to a lot of details. But so hopefully this session will give you some experiences from working with early adoption customers over the last year and a half. So I'll introduce myself. My name is Terry Story. I'm a global architect in Dell Services. I've been working with Windows Server 2012 for about a year and a half now, and Windows 8 at the same time, because the code is pretty much synchronized, about 87% the same code base. And I run the RDP, Rapid Deployment Programs, and the TAP, Technical Adoption Programs, working with early adoption customers. We've got about 15 customers running Windows 8 and Server 2012 on Dell today in production. And obviously through going through that process, there's a lot of learnings from that. And this presentation is to go through those learnings. So I'm going to specifically focus on one customer, and this is a host, a service provider customer called NTTX. And they're a customer in the UK. They essentially want to build a Greenfield data center from the ground up. And it was funny, the engagement started as a VDI terminal services discussion based on Windows Server 2008 R2 SP1. We quickly realized that based on the WAN, the latency requirements of the design, that would never, based on RDP7, would never fly, would never really work. So knowing that what was in Windows Server 2012 or Windows 8 at that time with RDP8, we looked at collaborating with NTTX, working with Microsoft and Dell product groups to build a solution that would service their WAN latency requirements. And this is when the journey began. And this presentation is to go through that journey with you and the learnings and the outcomes of that. Any questions so far? Okay. Essentially, this is the high-level agenda for this presentation. You guys will be able to take this away with you, and there's quite a lot of detail within it. So I'm not going to go through every single point. We've got an hour, and depending on questions, we can get through all of this. So as I said, NTX is a service provider in the UK. And this is about a Greenfield data center design based on Windows Server 2012 and Windows 7 and Windows 8 clients. And essentially, we want to build this on 12th generation Dell platforms and storage and networking capabilities. Essentially, their approach is to provide an end-to-end service, not just SharePoint, not just Exchange, but essentially put a Hyper-V server onto a customer's environment, provide file print, Active Directory, service, DNS services to that customer, and essentially facilitate all the capabilities, all the application services from that start, connecting authorization point, authentication point. And all those services can be either located on-premise within the customer or centrally provided by NTX as a service provider. And the whole idea of this design was to be able to build a solution that would reduce the cost per user per month for SharePoint, Exchange, and all the Microsoft core services by at least half. And how can we do that? Well, we had to reduce the storage, the networking, the platform costs, and get scale. And it had to work over WAN, had to work in such a way that we could provide local type performance over a terminal services or VDI session, no matter what the WAN and latency environment that we encountered. And RDP8 really shone through in being able to provide that. So I don't know if you guys know that RDP8 works on Windows 7 Service Pack 1 as well as Windows 8. So we were able to service this not just through the later technology, but obviously going back one step as well. And that worked pretty well. And I'll go through some numbers as we progress through the presentation. So RDP8 was a key fundamental requirement for this project. And obviously Hyper-V scalability. So in Server 2012, the Hyper-V scalability just goes off the scale. We're talking 1,000 VMs per server type scale. Obviously, you would never reach that type of level that you'll have some sort of bottleneck. But we've certainly scaled that up to, from a VDI standpoint, and reaching the right price points around memory and processor and disk to about 200 VMs per server. And I can provide more details on that if so required. Any questions so far on this? Fundamental design was to make it an architectural, the architecture in such a way that it was modular. So we could add storage, we could add platforms, and we can just scale out. If I go forward here. And this essentially is the architecture design. Windows Server 2012 is made up of many components. You've got cluster shared volumes, high availability file services. You've got storage spaces and pools. You can present Hyper-V services now through a WAC share. You've got various technologies around networking, remote RDMA, SRIOV. Some of those technologies you'll be learning this week. Are you guys familiar with RDMA, SRIOV? Okay. So this is to build an architecture like this, your network adapters have to support certain standards. Your storage, has to work in a certain way to work with storage spaces. And to build this up in such a way that it scales and be modular takes a lot of testing. We spent weeks in labs in Seattle, Microsoft's headquarters, on Dell R720s to look at all the pieces and where the bottlenecks were. And it took a while to figure out the network adapters that we needed, whether it was 1 gig network adapters, 10 gigabit network adapters, looking at the cost of each and the scale of each. And fundamentally, this is the design that we came up with. So the bottom box is a Windows Server 2012 highly available, continuous available cluster, file server storage cluster. And the higher level Hyper-V workloads are application workloads, so Exchange, SharePoint type services. And some of the singular nodes, some are clustered nodes. And between the top Hyper-V nodes and the bottom storage cluster is RDMA, to give us a way of exchanging information at near local speeds from memory to memory between two nodes. So essentially we could separate the file cluster and the application nodes with a network in between, but they are from a performance standpoint seamlessly local. And RDMA enables that capability. But you need to have network adapters that support that. And I'll go through later what network adapters that we have that support that from a Broadcom and an Intel perspective. So any questions on this architecture? I mean,
what was the reason to go for SMB, not having, I don't know, private channel storage or whatever behind the solution?
Okay, flexibility. So we wanted to be able to present this. So ideally we wanted a logical virtual volume that we could just keep plugging the storage into and just increasing the IOPS. And then from an application workload Hyper-V node at the top, point to that WAC share and just run the VHDX files. We found limitations in that you cannot have a shared VHDX file. So we've had a lot of discussions with Microsoft on when that's going to be solved. Right now we can't solve that. We need a nice, cozy presentation to solve that. But that aside, this scales and this actually works very well. So with a WAC share and RDMA combined, that gives you the scale. Okay, and as you guys probably know, you can actually put Hyper-V VMs on any type of configuration, and you can have storage live migration and memory live migration between a cluster, non-cluster, and one node and another. And RDMA just facilitates the performance of that from a storage standpoint. Any other questions on this? There's a lot of detail, and some of this you're going to be learning bits, as you go through various presentations this week. But the whole idea of this is that we could just take standard JBOD storage configuration, put storage spaces on top. Storage spaces gives you the ability to mirror, to RAID those disks and present it in a resilient way for CSV then to present it to the cluster, and then for the highly available, continuously available file services to present that to an SMB share. So essentially, no matter what happens, the application Hyper-V workloads can hit that WAC share, and if you have a storage failure, you have a node failure, have a network failure, there is alternative paths to that store, and it will still scale. And we wanted to, and this was based on 2-node that connected to each JBOD, and then we connected 2 times of that to create a 4-node cluster. Now, essentially, the highly available Windows Server 2012 cluster can now support 8 nodes based on the release candidate code base. So that's been doubled. So the whole idea is that we could just then, from a commodity standpoint, just purchase this hardware and just keep plugging it in and just keep scaling out. And we wanted to separate the application workload servers from the highly available storage cluster, if you like, presenting those VHDX files out. And obviously, we needed to be able to automate the build of this. In Windows Server 2012, the PowerShell capabilities means that we can just, through one DVD, plug it into a server and build the whole data center, and then keep building it and keep scaling out. And we've automated the whole of that process. And with workflow capabilities, you've got authorization and approval processes in place for that as well. Now, we couldn't do that for every capability. We had to use WMI in some functions. But essentially, we've now got this automated. So it's a complete end-to-end solution. Any other questions on this? Now, this is one of the things that we worked with Dell Product Group on was to get our PowerVault storage to support this configuration. Because prior to Windows Server 2012, we would not support a JBOD configuration in a cluster configuration, which meant that we could never get 2 Dell servers connecting to a PowerVault storage and share that in a cluster configuration. By working with Server Product Group, Dell's Server Product Group, we enabled them, we explained the requirement, customer requirement, and we work with them to get this resolved. This is now a supported configuration. So you can get Dell PowerVault storage, MD1200 range, 3600 range, and now plug that into a Windows Server 2012 cluster configuration. And it will be supported under storage spaces and presented in this kind of architecture. We also support storage spaces and Server 2012 on the Ecologic storage range and the component storage range, and I'll go through some of that later on. Okay. The other thing as well is you see at the bottom there the Platinum service and a Silver service, so solid-state drives and high-capacity drives with lower spin rate. So this storage configuration you can actually design in such a way that you can actually, depending on the speed and the capacity that you required, and obviously the cost of each, you could break that down even further. So we looked at various ways of creating this virtual single volume, and this is the I guess the closest we could get to that. So the WAC share is the presentation, if you like, for that volume. we actually wanted to reduce the amount of WAN shares for each of the storage presentations. But storage spaces and CSV won't provide that right now. And that's something we're working with Microsoft as we continue moving forward with this design. Okay. Let's go back. The other part of the architecture going forward was that we wanted to take that cluster, that storage cluster, and replicate that data off-site. So within Hyper-V 2012, you've got a capability called Hyper-V Replica. That allows you to synchronize and replicate VMs to an off-site location asynchronously every 5 minutes as a minimal sync time, if you like. And if you place that capability within a Windows Server 2012 cluster, that agent is a resource-type capability, so no matter what node fails, the service still continues. So from a central source perspective, you can now replicate VMs to multiple locations, and that can be on-premise, off-premise, depending on your requirements. And that could also be cert-based or Kerberos-based, depending on whether if it's obviously if it's Kerberos-based, it's part of the same Active Directory. If it's cert-based, it can be a separate security type authentication to another non-owned data center somewhere else by another hosted service provider. So this was very key that we had this capability. So you're building this core central architecture that's resilient within its own data center and scalable and flexible, but we need to be able to replicate the core services to another 1 or 2 or 3 DR locations. And the things that we found with this is that Hyper-V Replica allows you to replicate the VM, and based on that you fail the primary site, and then the secondary site takes over, it IP injects the IP address so you can actually continue. But that only works for core services within Microsoft. It doesn't work with third-party applications and not even IS. So there were some limitations with that. So we're continually working with the Hyper-V Replica team to get those resolved and working at workarounds. Any questions on that? Are you guys familiar with Hyper-V Replica? Okay. So this out-of-the-box capability within Server 2012. So lots of new capabilities there to look at a real good end-to-end solution that includes your ground-up architecture and scale, but also your resiliency off-site. Okay. So going back on the configuration of the Dell 12th generation platform, so this was based, the testing and the design is based on the Dell R720 with 56 gig of RAM. And this platform has support for 4 7800 ATI GPUs. So essentially, our testing showed that we could get up to about 25 virtual machines running remote effects with the virtual GPU for each of the servers. And that seems to be working quite well. We had to lower the processor speed and capability within the system to support the 4 GPUs from a power point of view. But we've got about 20 of those servers running in Seattle right now. We've actually got the engineers techs who are in Seattle right now testing this with Microsoft in this exact configuration. And we're building like 5,000 VMs in like 3 hours and testing latency over WAN with WAN simulators, with RDP8 and Windows 7 and Windows 8, and really scaling and pushing every aspect of this design. And it's really setting the scene for our solution design going forward for how to build a highly scalable and reliable system based on Windows Server 2012. Okay. Are you guys familiar with mirrored spaces as a capability? Okay. So mirrored spaces, is quite an interesting core capability within Server 2012. It's actually available in Windows 8 as a client as well. So it's out of the box, it's there with every SKU, and it essentially allows you to take simple disks and present them with a basic SAN capability, if you like, to to the cluster or single node, and to scale it out and to name it. And the learnings we found with this is that if you imagine that you've got a JBOD storage spaces, you've got a space and a pool, you've got cluster share volumes, you've got a SMB share, you get a failure in the disk. You want to track that all the way down through that software stack to the physical disk. You need to be able to do that. And how can you do that? Well, PowerShell has that capability now to actually go through the stack and to actually flash that light on that disk or that array to actually tell you where the actual storage space, pool and volume relates to the physical disk. So you can actually track that all down. And PowerShell has that capability as of, I think it's the beta release that was enabled. So you can actually now use PowerShell to automate the build, but also use PowerShell to find out where your disks are in relation to the configuration. So you can know where it is. Because if you imagine, that's a pretty complex configuration. So you need that automation. You need that capability to understand where everything fits in. And when there's a problem, you need those tools to figure out, how you can resolve that and where the problem's coming from. So these tools are going to help you. Okay. So another core aspect of the design was that we wanted a complete Windows solution. Windows Server 2012 out of the box pretty much gives you 70–80% of what you require. So the customer was very interested in that they didn't need VMware, didn't need Citrix, didn't need any third-party software, and they really scrutinized why they've used third-party software in the past. And if you're paying $100,000 or £100,000 for a particular feature, then it's questionable about whether that cost is relative to that feature. So it really made you focus about, do you really need this capability? So Server 2012 has a lot of features out of the box. There's just 1,001 things there. So by reducing the cost to serve, getting the right architecture with the right storage, networking and platform, and power with resiliency, and just reducing the third-party software spend was the final icing on the cake, really. And this version of Server 2012 really allows you to get to that stage, and we've proven it by the testing and the implementation we have in production today. It's RDP8 is fairly comparable to ICA on Citrix. There's Citrix resiliency type capabilities and management capabilities that are superior than 2012, but that's at the higher end, the enterprise. But we want to pay that large amount of money for that difference. And so there's a lot more choices there to really scrutinize and analyze, what you're going to do here. And Server 2012 really gets you to that point. So from our testing, we know RDP8 really works. So you can actually take a Windows 7 SP1 client, a Windows 8 client, have a very high latency network configuration and low bandwidth, and get a near local user experience. And what we found is that for Flash and I applications, it works very well, and over a 512 kilobit network. But if you want true voice and audio, you need 4 megabit per second type connectivity. And now as we move towards the RTM release to manufacturing release, is to actually get that down even lower. And we found that anything above 100 millisecond return time on the network, then your multi-touch on Windows 8 becomes a bit laggy. So there's a lot of other details that we found around what works best, how to configure it, how to scale the system out, and what you really need from a network point of view, and against the customer's requirements on the service and usability.
About how many users are you talking when you talk about different numbers for bandwidth?
So good question. So from a terminal services standpoint, we're looking, like in the 60s to the 80s.
So 4 megabit link would be enough for audio and video for up to?
Because terminal services now you can use a physical remote effects GPU. So terminal services in Server 2012 uses remote effects, so the server now renders and compresses. So it's only the pixels that comes down. So the data you receive over the network is far less now. the stream is far less compared to Server 2008 R2. So we can scale the numbers out more. So for 60 and 80 users, over the 4 meg link is quite usable. Yeah. Obviously VDI, a bit higher. Sorry, the numbers are lower. So we're actually finalizing these numbers as we speak over the next 2 weeks. And then to put this in place based on and then to quantify and cost the network requirements for each of these services for the customer. And there's hundreds of thousands of customers that are wanting this service from NTTX because of the cost reduction. What else is there? So imagine that if you have RDP7 today on Windows 7 SP1, and you fire up IE and you're paging down over a high latency, low bandwidth link, it takes you forever to get to the bottom of that page. You put RDP8 on Windows 7 SP1 or Windows 8 with RDP8, it's directly straight through. It's a more usable experience. It's actually comparable to a local physical desktop now. So terminal services and VDI becomes a lot more viable now with Server 2012 and RDP8, without having to go to Citrix to help you get to that usable sort of position. So a lot more choices here and reducing your cost. Any more questions on this? So to actually replace desktops? Yeah. Offline VDI. Yeah, exactly. So to repeat the question, so for a desktop system, terminal services and VDI within a LAN environment is very viable. But for a laptop, traveling user, multiple different types of medias and connections, it's more of a challenge. So yes, there's no offline VDI capability within Server 2012, but Windows 8 has its own hypervisor, Type 1 hypervisor, that allows you to actually move VMs from the Server 2012 Hyper-V environment to the client and backwards and forwards. And I wouldn't be surprised if some third party will be developing an offline VDI capability that will leverage that, because most of the architecture is there. You just need the ability to actually synchronize a VM from one server, centrally managed environment to your client, and to be able to keep that in sync based on it's connected or not connected. But when you're not connected, you can run offline and do everything that you need to do, and you don't know the difference. Now, our third-party companies out there do that today, but Windows 8 client and Server 2012, that has the capabilities to develop, I think, quite reasonably quickly once Server 2012 and Windows 8 is released to enable you there, and to provide it in such a cost-effective way. So we know Microsoft is not going to be doing that part to enable third parties to develop on top of that, to do that. Does that answer your question? Okay. Any other questions? Okay. So these are just points of interest around why RDP8. So RDP8 is based on the UDP protocol rather than TCP for its connections, and it's multiple streams. So audio and video come down in its own sort of channel, if you like. So that way you can squeeze as much data down a high latency, low bandwidth environment. And it's become very usable. So it actually handles and manages loss far better than RDP7. So if you look at Windows 7 and Windows 8 together, using RDP7 and Windows 8, you will see a substantial difference when the latency increases and the bandwidth reduces between the two. Windows 8, RDP8 still remains very, very usable. So I would urge you to, if you have a requirement to have a central data center where you have, and you want to provide this service across high latency, low bandwidth environments, I would urge you to start testing this and looking at its capabilities, because it's far, far improved. Okay, so again, single sign-on is a key addition to Server 2012. One login, one password to access, and the idea was to match user experience from a physical desktop to your TS and VDI session, no matter where it may be. Obviously limited to physics, obviously, but far, far better than prior configurations. One of the other improvements as well is that Server 2012 has a software GPU capability. So you don't have to go and purchase a GPU, a graphics process unit, to give you a remote FX capability. Out of the box, terminal services and VDI will support the software GPU. So for simple calculations that Office 2010 uses for graphics and 3D type capabilities, it will use that. And the code name is WARP, W-A-R-P, for this software GPU type capability. What it essentially does, it means that the cores and processes within the physical server do the rendering and compressing of that function, and then organize the pixels and presents that down to the client. Where in 2008 R2SV1, you needed a physical GPU to do that. One of the things around the GPU capability in Server 2012, you need a DirectX 11 GPU and DirectX 11 driver combined to support, for the hypervisor to support the GPU and for it to time slice it and present it to virtual machines. That's one of the requirements that got enabled at the release candidate. So it's one thing to consider when you look at remote effects. It's a lot more stringent in its requirements, obviously, from a scale and reliability perspective. From a Dell point of view, we can get 4 GPUs into a single R720 box. We're working with third parties to get our Blaze to support GPUs as a mezzanine card for Windows Server 2012. And we're looking at other enhancements later this year to give us more scale and more GPU options for remote effects. And we're working very, very closely with Microsoft on all those areas. Okay, this just goes through points of learnings and configurations. Obviously, with terminal services now, you've got USB redirect with remote effects, where in Server 2008 R2 you didn't have that capability. So now you can actually virtualize a link environment. So because now you can actually use RDP, connect into a VDI environment, it will now pick up from a terminal services point of view and VDI perspective your phones, your devices to give you audio and video capabilities over a virtual environment. So Windows Server 2012 and RDP 8 enables now link type capabilities in the virtual world. Okay, I think I've gone through all that. RDP 8 it will be supported on all the Windows devices. Still have to rely on third parties for anything that's non-Windows. So, that is lots of discussions we've had with Microsoft around on that, and I know that's been addressed as we move forward. Okay. So I've covered up some of these lessons learned. One of the things that you'll encounter as you test and explore Server 2012 is that certain capabilities don't work with other capabilities. So GGPication doesn't work with cluster shared volumes, for example. You need a separate non-CSV volume to enable that to function. And that was one of the things that we really wanted to get solved. So if you imagine you've got this scale-out cluster shared volume, you're presenting this to this application, Hyper-V service, and we wanted a way of consolidating disks using deduplication, and we couldn't do that with cluster shared volumes. So deduplication from a Hyper-V VHDX perspective means you can get a 90% reduction on size. So if you imagine you've got terabytes of VHDX storage, deduplication will reduce that by 90%. You apply that to your home and your home shares and your documents, you get a 30 to 40% reduction on your storage requirements. So just with deduplication in Windows Server 2012, that alone can actually reduce your storage costs and be a reason just for moving for Server 2012 from a file server perspective, a file server role perspective. And you can apply that to, and there's just 1,001 features like that in Server 2012. Okay. I think I've gone over most of these points. Any other questions on this? You want to be quiet. Is this all new to you guys? I guess the end of the week will tell, I guess. Just picking up some key points here. So a cluster in Server 2012 now supports 64 nodes. So you can actually scale out, quite large configurations. But it supports 4,000 objects, so 4,000 VMs, which are clustered highly available objects. If you don't make them highly available objects, you can have more than 4,000 VMs. So you can actually look at making, but what you don't do, you don't get patched virtual machines in a cluster, you don't get the priorities within a cluster. So Hyper-V in a cluster environment allows you to prioritize VMs about what starts up first, what is priority when a failure hits and it moves the VM from one node to the other. But the object has to be cluster managed. So this is the limit, the 4,000 object within the 64 node cluster. But you can, as I said earlier, you can use non-clustered virtual machine objects if you so desired. Okay. Okay, I've gone through all that. Okay. Just moving on to some of our capabilities in Dell Ecologic and component storage. We now support the copy offload capability, which is a way of telling the storage to move data from one location to another and let the storage do that on your behalf with no client interaction at all. And this doubles the network performance. So the testing we've done is that with no copy offload is about 104 megabits per second, just on some of the transfers we did with different LUNs on the same ecologic storage. And with copy offload enabled, we doubled that to 208 megabits per second. But the key thing is here, this capability can be supported and used within live migration functions. So if the storage supports copy offload and you want to live migrate from the data from one location to another, and it's a storage live migrate, it will do this in twice the speed. So there's some good areas of optimization there. Okay. That's essentially, just a graph outlining that. And you'll have, as I said, you can have a copy of those slides. From a SROV perspective, SROV allows the virtual machine to bypass the hypervisor and talk directly to the network adapter to give you near local network adapter speed. And these are the platforms that we'll be supporting SROV. So by RTM, we'll have that support. Right now, it's a BIOS update, if you like. So our 12th generation will support our SROV. We're just doing some final testing there before we release that BIOS update. And then our 11th generation numbers here will support SROV. So it is a BIOS function that we switch on. Any questions on this? And this will give you the information you need to go and check the tag on the system, whether it supports it or not as well. So to explain ODX as... Yes, it's doubled your performance based on the Ecologic 6000 range. So basically, we've got a beta program running right now that gives you an updated software pack for the current releases of Ecologic storage that enables this capability. And we're working with several customers around the world in testing this in production right now. And not only will it help you perform the data transfers between storage arrays and LUNs, but also it will support live migration and double the throughput of that. Some of the other key learnings we had as well, before I go into the SRV, is that Server 2012 has a capability called SMB Multi-Connect, which allows you to have multiple NICs between two nodes, as an example, and based on the traffic that's been exchanged from one node to another, it will use RSS within that's part of the driver for each of the NICs to determine what adapters it has, what bandwidth it has, and then to intelligently select that and enable those adapters to support the increased bandwidth requirements to service the transfer of data. So basically, it will scale up and scale down. But the beauty of SMB Multi-Connect is it allows you to say, well, this is the data I'm chucking through the system, and this 1 gig adapter will be sufficient to service that. I won't just select this 10G adapter. I'll just select what's required. So it does it intelligently. And we found that you don't need a 10 gigabit network fabric to actually build the architecture that I mentioned earlier. We looked at, looked at the cost of 10G, the switches. It's pretty expensive still at this stage. Obviously, costs will eventually come down. But we found that by using 8 1 gig adapters with RSS support, we were able to scale the system out and give the price point down. And that was the option that we decided to go for to service the performance, the scale, and the cost aspects of the design. And that's working very well. And basically, those adapters will be used based on the data being shoved between the systems from an architecture standpoint. Okay. So basically, this is just talking about the amount of throughputs we have between a non-SRV adapter and SRV. So SRV is pretty much, trying to solve the network bottleneck issue to allow a virtual machine in Windows Server 2012 to just scale to a physical machine. So you can have fiber-connected storage, SRV connected network adapters, 34 virtual processors per VM, 1 terabyte of memory support for each VM. So now you can look at putting your workloads that you've never considered to be virtualized on Hyper-V now, to reduce your costs even further. And so this opens up a number of opportunities there as well. These are the adapters that will support, so Broadcom, Intel, and QLogic are the 3 manufacturers that will support RDMA, SROV type capabilities, and I can give you the specifics, board and card numbers if required. Okay. So we talked about the SMB Multi-Connect, anything else? Consistent device naming is a key area of change. Imagine that you have 6 nodes in a cluster, and when Windows comes up, it names those devices randomly based on the GUID. Now you can actually name the devices, the network adapters, the storage adapters, consistently across all nodes now. So you know that they are the same, with the same name, and they're associated with the same device in the same slot across the board. We now support this in our BIOS for Server 2012 for our latest 12th generation servers. So this is going to make life a lot easier now. So you can actually know that what you see is what you get across all nodes. And then in this slide here, we've got a bit more detailed explanation about what that provides and how we provide that, if you have interest there. Okay. So essentially, just reiterating this, from a network adapter perspective, it just gives you consistency of device to naming relationships. Any other questions on this? It seems very quiet. So from a Server 2012 perspective, and from an OEM perspective, we've been working with Microsoft since day dot, really, and this is the most work we've ever done on a Windows release. So we specifically designed our 12th generation power, CPU, memory, and disk requirements around the capabilities within Server 2012. So 4K sector support in the disks, the core parking capability. So basically, if the system is not doing much, start switching off cores and processors, saving power, or to live migrate VMs from one node to another. So we do a lot more intelligence now within the platform in relation to Server 2012 that gives you the option to optimize and customize better. And we scale. We scale substantially high now with Server 2012 on 12th generation, beyond any other platform that we've designed and delivered so far. So, some real good things there for the future. And we continue to do that as we move forward with our next generations, our next storage, and our networking capabilities. And so this is just the start of that, more detailed relationship with Microsoft to achieve more scale and cost reductions. Any other questions on that? So I've got through this presentation pretty quickly. You must have some more questions. We're 15 minutes early, so. You've got questions on VDI, terminal services, any other functions or features you want to know more about in Server 2012 or Dell? So if that's a pooled VM environment, no. If it's a personal VM, yes. So personal VMs, I'd look at, maybe replicating somewhere else via Hyper-V replica, or, combined with maybe DPM.
You said you were replicating. Just in case something goes wrong with the VHD, so it goes replicated to the replica side.
Yes, it does. If it's a personal VM.
Yeah. So if there will be a problem because the replica will be also corrupted. So that's my question.
Good point.
Store the VHDs to a tape or something like that.
We do, yes. So the design is based on differential disks, so a parent gold and stubs. One of the enhancements in Server 2012 is that means that you can create a parent, and you can then create stubs, but you can move that parent around or take the stubs and associate them with different parents. So a new capability in VHDX means that you can have flexibility of differential disks and associate the stubs to different parents. So basically you're not copying the large pieces of data between the different hosts. It's just a stub file which is like 100K. Associate it with a different parent, and then once the stub fires up, it then grows into the full system. So for the most part, we take that approach for the core VDI infrastructure, and then we look at the personal VM aspect because users want to install their own applications, they want to create uniqueness of the configuration and user experience. But primarily it's about that they want the ability to install their own applications. They want administrator rights. Okay, but yeah, we use DPM to back up, and then we replicate as well, just to cover that alone.
So 2012 still does not support Windows Server backup tool for backing up the CSV?
Yeah, so we're working with Microsoft in the next release of System Center 2012, which does support CSV2, if you like, in Server 2012. So we're working very closely with Microsoft, and we're testing that. Yeah. So as part of the early adoption program, we are able to bring multiple early adoption programs together to do that. So, okay. Any other questions?
What's the use of the SOM?
Sorry?
What's the use of the SOM with Windows 2012? With the sharing of things like migration capabilities?
Yeah. SAN is still very important. If you take what I mentioned about copy offload, where you can actually move large amounts of data at the SAN level between different arrays and different LUNs, and let the SAN manage that. So your current investments in the SAN is still important. But as you go forward, I think what happens with Server 2012, you don't just need a SAN. You can look at JBOD, local storage now, because you can actually hold that, use those storage mechanisms to hold, content for Server 2012, and it will leverage it because you don't need a SAN for live migration, storage live migration now. So I think it doesn't remove the requirement for a SAN. It just puts the SAN in its own classification based on your scale, your usage requirements.
When will you need a socket? Because in your design, you supply the SMB by the build software.
So I need a SAN when I'm moving a lot of data around often. And I want to be able to back up from a SAN perspective using the SAN-based software. So there's a lot of SANs have obviously a lot of intelligence there, where the storage I outlined had no intelligence. It was just a bunch of disks, and storage spaces presented it in a resilient way, with the capabilities to look at, bad sectors, how can I recover from those bad sectors, how can I move data around. So at a low level, it dealt with those issues. But what it doesn't do, that architecture didn't support copy offload, so it doesn't support the higher performance capabilities that Server 2012 and a SAN combined provide. Okay? So Server 2012 enables multiple storage options, and based on your requirements, cost, functionality, you can have more choices. That's what it gives you. So it doesn't remove the requirement for a SAN. It means that you can now use cheaper storage for other requirements that may not need a SAN. So it allows you to think more and reduce your costs in that area. Okay. Any other questions? Okay. Thank you very much.